All right, section 1.6 hopefully is pretty familiar. It's something that we hammered home a decent amount in the beginning of Algebra 1. Sorry, scratch that. The beginning of semester 1 of Algebra 2. That's what I was trying to say. So the first function we're going to talk about here, the parent function, it's f of x equals c. This is actually one of the parent functions we didn't talk about. This one is just called a constant, where c is just going to be some random, well, not necessarily random, just some value. So for example, with this one, we're just going to pick f of x equals 3. So it's going to have a horizontal line at y equals 3, and it's just going to be flatlined forever. So the domain down here, the domain, talking about the x values, x is an element of the reals, and that's it. Our range, we're always going to start off with what types of numbers. Range is an element of the reals. And looking at our specific graph here, the range is always y equals 3. Now, in general, it's going to be some other, it could be some constant. So we're going to say y equals whatever the constant is, c. In this case, specifically, it's 0. Sorry, 3. Goodness gracious. Intercepts. We have a y-intercept. And that's going to be whatever that c value is. In this case, it'd be 3. X-intercept, well, looking at this graph, there isn't one. Now, there is a case when it could be. That would be unless f of x equals 0. Then it would be constantly, and let me draw what that would look like. It'd constantly be on the x-axis, so technically it would have an infinite number. So if we're talking about that one, it'd have an infinite number of x-intercepts. We're not going to worry about that too much right now. For symmetry, this one's symmetrical if you reflect over the y-axis. So again, if you use that y-axis, kind of cutting that in half, if you're drawing a mirror, oops, nope, that's not the one I wanted. If you're drawing as if there were a mirror here, it would reflect over that y-axis to the left and to the right. Technically, it'd be any vertical line would work. If you do a vertical mirror over here, it would work, but it doesn't make a difference. Other properties, that's really it. It just can reflect over any vertical line. So I'm not going to bother writing anything with that. The second one in the upper left here, sorry, the upper right, goodness gracious, teaching backwards is throwing me off. F of x equals x, that's just linear. Now, you might also argue that constant graphs are linear, and that's true, but this one's the very specific type of linear. So, the linear graph, f of x equals x, if you make a x and y table out of it, you got x values, you got y values, you can pick whatever x values you want, but I'm going to still choose the ones that are just easier, -2, -1, 0, 1, and 2. And when we plug those into this function, we end up with -2, -1, 0, 1, and 2. The x and the y coordinates end up being the exact same for the parent linear function. So if we graph this -2, -2, -1, 1, 0, 0, 1, 1, 2, 2, and folks, this pattern is going to keep on going forever. So we can draw a straight line going through those points and just keep going forever and ever and ever. Speaking of going forever and ever and ever, its domain, it's going to be any x value we want, any real number we want, with no restrictions. Same for the range. The y values, it's going to go up forever and down forever and everything in between. And that's it. So the intercepts, for any linear function, you're going to have one y-intercept and one x-intercept. In this parent linear function, they're both at 0, 0. The axis of symmetry, goodness gracious. It's symmetrical over any perpendicular line. I'm going to use that symbol. It's like an upside down T. Sorry, let me move my image so you can actually see what I'm writing here. So any perpendicular line. So this one would have a perpendicular line that would run like maybe like that or anywhere else. Any perpendicular line to a linear function will be a axis of symmetry. Okay, let me move my image again. So I'm over here. Clearing out. There we go. Okay. Next up, f of x equals x squared. That's a good old quadratic. So let's choose those same, I'm going to choose those same x values just for simplicity's sake. X, y, with a -2, -1, 0, 1, and 2. And we're going to square each of those. So -2 squared is 4, -1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4. I said it, but I wrote it wrong. So we've got coordinates at -2, 4, -1, 1, 0, 0, 1, 1, 2, 4. It's got that nice smooth curve, that parabola shape that we like so much. And it looks like this. Domain, again, is going to be x is an element of the real. So you can plug in any real number you want and square it. That's not a problem. For the parent function, for this range, it'll be the y values. Y's are elements of the reals. But for this parent one specifically, you'll notice it doesn't get below 0. So we're going to say y is greater than or equal to 0. In general, for the y-intercepts, there's only one y-intercept. There will always be a y-intercept. And then we're going to say up to 2 x-intercepts. Now, looking at this one specifically, there's only one x-intercept, but you could also draw one that has a parabola like this, and that goes through 2 different points. Or you could draw one that goes upside down or right side up, that doesn't touch the x-axis at all. So it can have up to 2 x-intercepts. Its symmetry, it has symmetry over the y-axis. So we can say it's reflective symmetry over, sorry, my stylus is being fussy, the y-axis. Or, you might remember this from Algebra 2, your axis of symmetry. We'll talk about the axis of symmetry, the AOS, later. Other properties, it's always going to have a max or a min, but never both. So if it's got an upward facing parabola, it's going to have a minimum. If it's a downward facing parabola, it's going to have a maximum. Last one on this page, and then we'll flip over to the next one, or next page. F of x equals x to the third. You might say x cubed. This is called cubic function. Let's make a quick table. So instead of raising it to the second power, we're going to raise each of these to the third power. So we got -2, and I'm just going to go through piece by piece. -2 to the third power is -8. -1 to the third power is -1. 0 to the third power is 0. 1 to the first or third power is 1, and then 2 to the third power is 8. So our graph's going to look a little something. I'm going to have to go off the screen, but off the graph. So -2, -8's about right there. -1, -1, 0, 0, 1, 1, and 2, 8. We're going to estimate it's about there. So this one's got kind of more of an S shape going on. Oops, sorry. Goes up through there. Those arrows go up and up and up and up. Domain, just because it kind of ran out of space there. I'll shift it over. We got x is an element of the reals. You can plug in any real number and cube it. No problem. Range. You'll see it, we get a bunch of negatives, we get a bunch of positives, and everything in between. We're going to say y is an element of the reals. Nothing else. The intercepts. It's always going to have at least one y-intercept. And then we're going to say up to 3 x-intercepts. Now this one only has one x-intercept, but you could have a cubic that looks like this, where it touches the axis 3 times. We're gonna say it's gonna have up to, sorry, let me move my video again. It's gonna have up to 3 x-intercepts. The symmetry, this one is rotational about the origin. Let me zoom in a little bit. It's rotational about the origin. Now it's going to change depending on what type of cubic it is, but the parent function is rotational about the origin. So if you were to take this graph centered on this, kind of like spin it around where this goes around, you'd end up in the same spot. So if you rotated it 180 degrees around that, it'd be the same graph. Other properties, it can have a local max and a local min. sorry, and a local min. So it can have a local max and a local min. Remember, we're using the word local max and local min because on a cubic graph, there is no absolute max, because max, it's going to go up forever. It's also going to go down forever, so there's no absolute min, so it's going to have those local max and local mins.